Okay, so in this video lecture series, we are going to discuss about the model deployment. Let's prepare our data for training and splitting it into the training and validation data so that we can select which model performance is best as for the use case. We will train some of the state of the art machine learning classification model and then select best out of them using validation data. Let's say we have a best quality and so we are looking for what for which quality if it is something that is our following the condition. So again, I will explain you in this situation what we are doing. We are trying to prepare our data for training and splitting to the training and validation data that we can select which model performance is best as for the use case. So for that, what we want, we will train some of the state-of-the-art machine learning classification model and then select best out of them using validation data. So let's say we have a column with object data type as let's replace it with the 0 and 1 as there are only two categories. White is for 1 and red is for 0. So after segregating features and the target variable from the data set, then we will split into 80:20 ratio for model selection. Features equal to, we can say df dot drop quality comma best comma quality x is equal to 1. Finally, we can check with the target equal to df best quality. So we can train and test and train and test. So we can train this. After that, we need to normalize the data before training, help us to achieve stable and fast training of the model, right? So why we are normalizing it? We are normalizing the data before training, help us to achieve stable and fast of the model. So that's why we are just normalizing it. Min max scalar we are checking, and then we are checking the non-fit transformation. After that, we are normalizing the data before training, help us to achieve stable and fast. That is the same thing. So we are training our data set. Before training, we are doing the normalization of the data. So norm.fit transform extend, norm.transform x-test. So after that, we have from training. So as you can read here, so we have what we have written exactly here. You can read it. Right, train some instead of the R machine learning model. If we can use the logistic regression XGB classifier as we see. So we are checking with the for I in range or I dot fit. Okay. So we will check one by one which one is a great prediction. So we are predicting a training accuracy, and we are checking the ROC and score for that. Y train model that predict X train. Similarly, we are checking the validation accuracy matrix that ROC AUC score Y test model I dot predict X test. So I hope everybody is getting. So I equal to I in range 3, 0, 1, 2. So basically it will list 0, that means logistic regression will check. Similarly, will check for XGB classifier and it will check SBC. Right? So I hope everybody is getting. Okay, so what we are getting the output, we are getting the output we can check that we are getting the training accuracy 0.70, we are getting the validation accuracy 0.69. Similarly, we are getting the from XGB classifier we are getting 0.76. From here we are getting 0.72. We are getting SBC. So we are getting training accuracy, we are getting 0.61. For validation accuracy, we are getting 0.58. Model evaluation. From the above accuracy, we can see that logistic regression and SBC classifier performing better on the validation data. Yes. So from the above accuracy, we can see that logistic regression and SBC classifier better on the validation data with less difference between the validation and training data. Let's plot the confusion matrix as well for the validation data using the logistic regression model. So we can plot the confusion matrix. Right? So I think you can understand. So we are plotting the it for what? 0, 1, 2, right? So best one is logistic regression SBC. We can see that logistic regression SBC performing better on the validation data with the less difference. And then let's plot the confusion matrix as well for the validation data using the logistic regression model. So similarly, we will try to do the same tricks for the elastic regression model because it's like a better accuracy. So we can do the classification here. Like we can get the accuracy here by using the computer matrix. So we are doing the X test, Y test, and then we are like done the classification report for the best winning model. Matrix dot classification report Y test model one dot predict X test. Precision recall F1 score support 0 1. Okay, so F1 score is nothing but the harmonic mean of precision recall value. Okay, so I think that's all. Thank you very much, guys.